Hi everyone. We're about to do lesson 8.6 and I do want to encourage you by just telling you that this is going to be kind of an easy one. You're going to want your books with you as you go through it, and you're going to want to open to after chapter 10 where it says appendices. So appendices right here. We're going to be working with appendix B, the integration tables. And basically what we're going to do is figure out which integral this most resembles and then use the table to figure out the answer. We won't have to go through the integration process, we just immediately go to the final response. So it says, so far in this chapter you have studied, apologize, yay, I have a lot of those. You have studied several integration techniques that can be used with the basic integration rules. But merely knowing how to use the various techniques is not enough. You also need to know when to use them. Integration is first and foremost a problem of recognition. Being able to recognize how one integral is different than another. That is, you must recognize which rule or technique to apply to obtain an antiderivative. There's times where U sub is going to make the most sense. There's times where trig substitution is going to make the most sense. And maybe both of those work, but which one is going to be the most efficient? So you need to recognize ahead of time what direction that you're going to be going. Frequently, a slight alteration of an integrand will require a different integration technique, or produce a function whose antiderivative is not an elementary function, as shown. So these are not necessarily just simple. They all look kind of similar, but they're all done in very different ways. All right. We're approached with this example. It says the integral of technically 1 over the quantity x square root of x minus 1 dx. And we need to figure out what category this falls into. Okay, so a couple things to be mindful of. What do you notice? I noticed that the x and the x here both match. I also noticed that I have a radical. Okay, that piece of information is going to be incredibly helpful because if you go through right from the beginning, you'll see that a radical doesn't even show up in the majority of these. Now we could argue maybe a radical for rule number 5 if the exponent was 1/2, but it doesn't really fit into the category of having the x on the outside as well. So I'm going to scan until I find something that has radicals in it. And I see radicals down at the bottom here. Pull this down at the bottom. Okay. And keep in mind, if you don't find it right away, there are 100 different formulas that you're going to be presented with. So it might take a little while to scan. All right, so I have a radical in the denominator, which means 17 and 18 both apply. I also have the u value first. Remember, the function is the u value minus the constant, and neither of those fit into that category. However, this does have the x out front. So arguably, we might have an a value of -1, right? And this could be written in a different order. So we'll come back to 17, and keep in mind, if it is 17, then a would be -1, and we would use this function. So let's go through and make sure it doesn't fit anywhere else. It's not going to fit anywhere over here. You've got trigs almost the entire way up. Go to the very top, and there's only a handful that have square roots in the denominator. It's going to be difficult to show. Normally, I would have a packet for you guys to reference quickly, so I apologize. Please do not write in your books. Okay, once you make your decision, just write it off to the side. Doesn't have the u first, doesn't have the u first, none of them have the u first, so it's not anything on that page. Move my camera here. I've got this down here, which says u squared. Not really like that because I had just a regular u, even though square root of x, I guess, could have been the u value. So nope, doesn't fit, doesn't fit, doesn't fit, doesn't fit, doesn't fit. Doesn't fit, doesn't fit. Nothing over there. And I don't see anything on the last page that applies either. Okay, so my best bet from what I've seen is number 17. All right, so this is how you would do the problem. I would write down that I'm going to use rule number 17. Okay? And I'm going to assign my u and my a. My u would be the x that I see both on the inside and the outside. My b, which would be the coefficient of u, is 1. My a, which is the constant that's being added, is a negative 1. If you don't see it quite clearly, I could have written this in a different order with x and then negative 1 plus x, and then you would see it does more resemble what this looks like. Okay. So if these are all assigned appropriately, and I look at my two choices here and I know that a is actually less than 0, which it is, then all I have to do is copy down this formula. Okay, inside the radical is a negative a. Well, if my a was negative 1, this is a negative 1. Arctan of the square root of a plus bu, that was the original radical, over negative a plus c. Now certainly this does not look really appropriate. There's a lot of cleaning up to do, so I'm going to take a moment to do that. My final answer, well, let's see, I've got a negative negative, which makes that a positive, and the square root of 1 is 1. So my coefficient is just 2. Arctan. I'm going to write my radical the way that it did look, just to be consistent. This is now x minus 1 over 1, so just x minus 1 plus c. Okay? And that's what it should have come out with. The sun is shining all of a sudden. It's changing my picture. Change this a little bit. All right, so if you have any questions, obviously, there's also a possibility of having more than one of these work. And if that's the case, then I ask you to challenge me. If you see that this would fit somewhere else better, then by all means, ask me about it. We'll talk about it, and maybe yours would be a better choice than mine. Okay, keep going. All right, let's look at what I have. I have a radical, okay? That's important. I also have my x's related in a strange way. This x is x to the 4th, and this x is just plain x. And we know that normally they don't write like u to the 4th and u on the outside. What they're likely to do is say that this is u squared. Okay? If that's u squared, then u would just be x squared. So think about this for a second. This is not u, right? The inside and the outside functions are not a squared version of one another. However, this could easily be part of the du experience. Now, what made me think to do that? Well, if they differ in degree to an extent that one is just not the same as the other, or even half of the other in degree, then chances are there's going to be some manipulation going on in the u substitution realm, if you will. So I'm going to keep track of some information that I'm finding out. What do you suppose a is? Well, if this is u squared, then that's probably a squared, which means a is 3. Okay? So let's look and see what category this might fall into. Okay? Again, we've got no denominator, and what's inside is not the same degree as what's on the outside. So down here, it's the outside that's larger. No denominator, so I can skip those. I can skip 19 through 22 because they're all fractions. 23, 25, fractions. 26 is looking closer. As I scan down, 26 is going to look the closest, because here's why. Go back to 26. Remember that x that was on the outside wasn't actually a version of the u squared, but it was tied in with the du, right? We just moved it to the side. However, it's not a perfect du. The du that we need is 2x dx. And we're no stranger to putting in a 2 and balancing it with a 1/2. That's not news. So now this looks just like rule number, where was I? Number 26, which says, and I'm going to put the 1/2 on the outside because now, I didn't write it, so maybe I should have. That's what it says now. This, if it didn't have the 1/2 in front, would have 1/2 in its answer. So let's look at 26. Oh man, this is going to be a nightmare. It's not very big. For 26, the answer gets 1/2 in front of it. Not to be confused with the 1/2 that we started over here. So there's a new 1/2. It's then followed by, and actually I'll just write it over here. So rule number 26 says the integral of u squared plus minus a squared du is equivalent to 1/2 u squared of u squared plus minus a squared plus minus a squared natural log of u plus the square root of u squared plus minus a squared plus c. Okay. So now that'll be a little bit easier. I'll write this all down. 1/2 times u. And remember, this portion right here is what we were comparing up here, so I'm just going to rewrite it as it appears up here. It's x squared minus 9 squared, or x squared minus 9, sorry. And it says plus or minus. Now, if you notice, this plus or minus is written in the same direction as this plus or minus. Sometimes what you'll see is instead of a plus or minus, it'll write minus over plus. Because this says plus over minus and it matches this plus over minus, we're going to maintain the symbol that was in the original, which is a minus. Okay? A squared is 9. Natural log, natural log of u plus the square root of x squared minus 9 plus c. Okay, that looks awfully messy, so I'm going to clean up what I can. This 1/2 is going to be distributed, making this 1/4 x squared times the square root of x squared minus 9. Minus 9, and see this 1/2 on the outside? There's also another 1/2. So this is 9/4 natural log of x squared plus x squared minus 9 square root plus c. Okay, rule number 26. Alright, let's look at the next example. What identifications can we make? Well, I see this e, and I see that there's an x in the exponent as well as the numerator. I also see that they differ by 1, so there's probably a u-du relationship between the two. And I'm going to go with that and see what happens. If u is negative x squared and du is negative 2x dx, then I'm going to balance this. Okay. The negative 1/2 is irrelevant when you find your rule. So I'm looking through my choices to find 1 over 1 plus e to the u. Scan your pages. I'm looking specifically to see if e shows up before I make any decisions further than that. I see some e's. There it is, number 84, rule number 84. And rule number 84 says this, and I apologize, if you don't have your book with you, it's going to be impossible to do this lesson. So make sure that you have that as we go along through this process. Rule 84 says the integral of 1 over 1 plus e to the u du is equivalent to u minus the natural log of 1 plus e to the u plus c. You don't have to integrate any of that. All you have to do is fill in the blanks. I didn't identify this as a. You could have, but you see that this shows up as 1 plus e to the u. So it's specific to our example. I didn't have to go any further. Final answer, or at least the final answer before any cleanup might need to happen. U gets written first, minus the natural log of 1 plus e to the u, which is the original exponent, plus c. Now you can leave it alone if you don't want to distribute that negative 1/2, or you can distribute the negative 1/2. It's not going to hurt anybody. I'm going to choose to distribute because it eliminates having too many negatives and it brings me into a positive value or a positive looking function. I get x squared over 2 plus 1/2 natural log of 1 plus e to the negative x squared plus c. And hopefully you made a mental note that this was not an absolute value, but rather parentheses. And I hope that once you saw that, you realized that 1 is positive, e to any power is positive, so there's no need to put absolute values around this because it will be positive regardless. Okay? And number 84 on that one. Keep going. All right, I see a mix between an algebraic function and a trig function. Normally we would have done this with separation by parts, the UV situation, but we're not going to do that here. We're going to scan through our choices, and I apologize for not bringing the book back and forth, but I think you understand. We're just scanning through, give you time to find it yourself. And I hope that you stumble upon rule number 54. Okay? Rule number 54 says the integral of u to the n sine u du is equivalent to negative u to the n cosine u plus n integral of u to the n minus 1 cosine u du. In essence, what they did was just give you the formula after one round of integration by parts. It's not going to have the entire answer because it's going to be completely dependent on how large that exponent is to begin with. If it's small, it's only going to have a couple terms. If it's large, it's going to have significantly more. But let's do what we can with what we know so far. By the way, what is u? In this situation, u is x. That makes du dx, which means we're all good to go. No balancing is necessary. We also should identify what n is, which is the exponent here, and that's 3. So this is telling us that through one round of using Rule 54, we get negative x cubed cosine x plus 3 integral of x squared cosine x dx. Now, this isn't complete, but it's better than what we started with because the exponent is in fact decreasing. Okay? So I'm going to make a note. What rule does this new integral fall under? And if you scan close to where we just were, rule number 55 would apply. Same idea as before, except now the n value is 2. I'm not going to write out what the rule is, but I will let you see it right here. This is what we can replace the integral of x squared cosine x with. Okay. I'm going to write that off to the side, you can. But it's not going to, well, maybe if I put this up here. Okay. So the first term doesn't change, the 3 doesn't change, but I'm going to replace the integral itself with u to the n, which is x squared, sine x minus now 2 integral of 1 less sine x dx. Always take a second to clean up what you have in front of you. Get rid of parentheses at all costs if you can, because you don't want a whole trail of several parentheses going on. Be a nightmare. Alright. This is better than before, so I'm going to apply rule number. You could apply rule 54, but this is more specific to 52, which is when you have one single x value in front of the sign. Okay. Notice there's no integrals in this, so we know that we're going to finish the problem in the next step or two. Alright, negative x cubed cosine x plus 3x squared sine x minus 6, and then I'm going to replace it with sine x minus x cosine x plus c. Do not leave that unsimplified. Now, I'm also going to change the order here of these two terms simply because this one doesn't have an x value and I want it in decreasing order, descending order. Negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x. Let's see. Okay, so several rules applied, and that's something to be mindful of. You might not be able to solve the problem in one step, but is your step leading you closer to something that is solvable? All right, before I go on to the next example, what can I identify here? I see matching x's, but non-matching coefficients. My a, which is referred to as my constant, would be 3. My b, which is the coefficient of my x value here, is negative 5. If this is in a 3 plus negative 5 way. If I see an integral in my choices that says a minus bx, then b would be a regular 5, a positive 5. And this 2 is getting in my way, so I'm just going to bring it out front as 1/2. Is this integral balanced? Okay, well, u is x, du is dx. However,
if u is this entire portion 5x, then du would be 5x dx. Now, notice where this x is. It's in the bottom. So I'm looking for an integral that has an a value, a combination of like a b, u, and then a u in the denominator. It also has to have a radical. There's a lot of criteria here. So let's go through this one together. Okay, I don't see radicals for any of these.
I don't see radicals for these. I do see radicals for these, but not where the radical is on the top and the u is on the bottom. To simplify my view even further, I'm not going to use anything with trig. I'm not going to use anything with e's and natural logs or arc inverse trig. And at the bottom, all of those have the radicals. Can't see it over there. Radicals are in the denominator, if there's a radical at all. But either way, that's not what I'm looking for. So I have decreased my scope to 19 through 45. Okay. We're just going to go one by one until we find something that fits into the category. Again, we want the radical in the numerator. 19 has a radical in the numerator. 20 has a radical in the numerator. The difference is, in the denominator, the u has an exponent that looks like it's greater than the one inside the radical. So it's definitely not 20. It's not 21. It's not anything that has the radical in the denominator. These aren't fractions. This one has a squared, which I'm not feeling. All of those are squared. We don't want anything with squared. So that eliminates our view to just 19. Okay, it's a linear radical. I'm going to write down what Rule 19 says. It says the integral of the square root of a plus bu over u du is equal to 2 square root of a plus bu plus a times the integral of 1 over u square root of a plus bu du. Okay. Now we're going to see if that helps us tackle this problem. All right. So if this is of the form a plus bu, then we can settle that b is going to be a negative 5. It's got to be connected to the 5, and we'll replace that middle sign with a plus. So it's plus negative 5. That means that my answer is now 1/2 times 2 square root of a plus bu, which is just this 3 minus 5x, plus a integral 1 over u square root of 3 minus 5x dx. Simplify what I see in front of me. The 1/2 with the 2 cancels, and the 1/2 with the 3 becomes 3/2. So question, we have another integral here. So what integral does this now resemble? Keep in mind, we have changed what we had before because now the x and the radical are both in the denominator. They're still both linear, which to me, as I'm scanning, I see number 21. Just slightly down. Rule number 21 says, I'll show you here in a second. Rule number 21 has the radical in the denominator. Nope, that's not what I want because u needs to be down there with it. So I apologize, not 21. Looking. I'm not seeing it here. We need it next. Okay, there it is. Rule number 17. Rule number 17 right there, where the u and the bu are on the same level. So I apologize. Instead of 21, we're going to write 17. And I'm going to write down what 17 gives me. 17 says, and this is for an a value that is greater than 0. So we're going to replace this with 1 over the square root of a, natural log of a square root of a plus bu, which is just what we started with, over the square root of a plus, a plus bu minus square root of a, and a plus bu plus square root of a. Let's see. Clean it up real quick. I'm going to also rationalize this, and by rationalizing it, it means that I'm going to multiply by root 3 over root 3. It makes this a 3, which when I distribute this, that's going to cancel with that, leaving me square root of 3 minus 5x plus root 3 over 2 natural log of root 3 minus 5x minus root 3 over root 3 minus 5x plus root 3 plus. The hardest part about this lesson is choosing the right formula, but even if you choose the wrong formula, you'll likely figure out very quickly that it's the wrong formula, and you just do it again. All the formulas are presented in front of you. Just don't jump to a conclusion when you know it's not the right one. And make sure that you identify key characteristics that are specific to that problem, like radicals or like trig. If I know that I see trig, then my first thought is to go to the trig section. But if I don't see this specifically in the trig section, then I start becoming creative. Okay, if this is not trig, then is this like a U, and do I have a DU, you know, or something along those lines. So keep that in mind. All right, so right now I'm looking for a trig function that has a fraction, okay, that completely eliminates the first few pages. And I am currently looking at the last page. Maybe go back a little bit. I jumped ahead too far. All right. Here's what I see. The closest thing I can find is this guy right here. We can see it. Rule number 57, which has a 1 plus cosine u on the bottom. Okay? So far, that's the best I can find. If that's what I use, then I need to have the right corresponding du, but here's the problem. The derivative of cosine is negative sine, not negative sine double angle. Okay, so that's not quite right either. Keep looking. Okay. And I see it nowhere. Okay, so this is what I was hinting at before. If I don't see this specifically, then I need to be creative. If this is u, that's not yet du. In fact, I shouldn't have a double angle for my numerator, so I'm going to rewrite this to maybe make it a little bit easier. I know that sine 2x is sine x, sorry, 2 sine x cosine x. Okay. Is that helping? It's not looking like it's helping to me. Let's see if we can go further. Still be creative. If this is u, then a negative version of this would be du. And then I would have another u in the numerator. So here's what I'm seeing. I'm going to use this as u. Okay? Again, it's just trial and error to see if this works. I have to balance it. I'm going to bring that 2 out front, this 2. I can't do that here because it's got the plus or minus. But this 2 can come up front. Cosine is u. Negative sine x dx is du. And then I have 2 plus u in the bottom. Does that help? Well, now I know that I'm not looking on the trig pages, but rather in the u and the a page. That would make this a. Do I have an integral of u over a plus u? It seems pretty basic, so I'm going to look at the very beginning. And I do. I have something very similar in rule number 3. The only difference is my coefficient b would just be a 1. So here's what rule number 3 says. The integral of u over a plus bu du is equivalent to 1 over b squared bu minus a natural log of a plus bu plus c. Right, write down what I know. That means, okay, a is 2, b is 1, so this starts with 1 over 1 squared times 1u, or in this case just u, minus a natural log of a plus u plus c. Now a couple problems here. Did we start with u to begin with? No. So I'm going to replace the u with what u was in the first assignment, cosine x. I'm also going to distribute and simplify this. This 1 just stays 1. You end up with a negative 2 times cosine x minus 2 natural log of 2 plus cosine x plus c. Or if you want to distribute even further, negative 2 cosine x plus 4 natural log of 2 plus cosine x plus c. Okay, real quick before I close this up, I do want to address one of the things that I mentioned. I need to find an example of it, so give me a moment here. I should have looked this up ahead of time, but I did not. There we go. Okay. Look at rule number 73. If you started with something that looked like 1 plus secant u, then notice here the opposite presentation of the plus minus. The minus is on top. So all this is saying is if this starts as a plus, then prefer a minus over here. If this starts as a minus, then prefer a plus over here. Either way, they have opposite signs. Okay? Expect on your test for the second half of this chapter to just have maybe 2 examples, and you'd have the book in front of you. All you would have to do is find the one that most likely it resembles, make sure that it's balanced, and just copy down the answer according to the rule. All right, and there is section 8.